Now we'll explore relationship between parabola and quadratic expressions. So we know that any quadratic expression can be written as y equals ax square plus bx plus c, where a is unequal to 0 and a, b, c, they are real numbers. So what I'll do is I'll take this a common. So I'll write y equals a. I'll write this is x square plus b upon ax and plus c upon a. Now I'll complete this perfect square. So I'll write y equals a and this is x square plus b upon ax, and then I'll add b square upon 4a square and I'll subtract b square upon 4a square and then plus c upon a. So if I'll complete this perfect square, I'll write it as y equals a and it will be x plus b upon 2a whole square, and here if I take 4a square as LCM, then I get minus b square plus 4ac, and if I take minus common, so it will be b square minus 4ac, and which is nothing but discriminant of this quadratic expression. So I'll write y equals a and here will be x plus b upon 2a whole square and then minus b upon 4a square. So I'll write it as y equals a into x plus b upon 2a whole square and then minus, here will be b upon 4a. So I'll take it on the left hand side. I'll rewrite this equation as x plus b upon 2a whole square is equal to 1 upon a and then y plus d upon 4a. Now if we compare it with the standard equation, we know that it will be x square equals 4ay when this 1 upon a is positive. So if a is greater than 0, then we'll compare it with the third form, and if a is less than 0, then we'll compare it with fourth form. So this quadratic expression, it will represent either third form, which is parabola opening upwards, or it will represent fourth form, which is parabola opening downwards, depending on this value of a. So if a is greater than 0, it will represent a parabola opening upwards, and if a is less than 0, in that case it will represent a parabola opening downwards. So if I'll consider this first case, when a is greater than 0, then if I'll compare, I'll write capital X as x plus b upon 2a, capital Y as y plus d upon 4a, and then I'll write 4a as simply 1 upon a. Now if I have to write vertex of this parabola, so we know that its vertex will be capital X equal to 0 and capital Y equals to 0. So capital X in this case is x plus b upon 2a and capital Y is y plus d upon 4a equals 0. So its vertex will be at minus b upon 2a and minus d upon 4a. Even if we'll take the fourth form, in that case also we'll get the same vertex, which is minus b upon 2a and minus d upon 4a. Now comparing it with standard equations, we can always write its focus, directrix, axis, everything for this given quadratic expression. So let us consider a question, and that is, find the locus of the vertices of families of parabolas y equals a cube x square upon 3 plus a square x upon 2 and minus 2a. So if I look at this equation, I see it as a quadratic expression. Suppose it is ax square plus bx plus c. Now for this quadratic expression, we know that this a is a parameter, because if a is going to vary, we are going to get family of parabolas. Now we already know for this quadratic expression, vertex is at minus b upon 2a and minus d upon 4a. Now a in this case is a cube upon 3, b is a square by 2, and c is minus 2a. So we'll find d is b square minus 4ac. So there'll be a to the power 4 upon 4, and then minus 4. What's a? A is a cube upon 3 and then minus 2a. So we'll get 3a to the power 4 plus 32a to the power 4 upon 12. That should be 35 a to the power 4 upon 12. So vertex of this parabola will be minus b upon 2a. So it should be minus, and what's the value of b? So value of b here is a square by 2. So I'll write minus a square by 2 upon 2a. So 2a here will be, so 2a, it will be 2 a cube upon 3 and then minus d. So minus d in this case is minus, and value of d is 35 a to the power 4 upon 12 upon 4a, and 4 in this case will be 4a cube by 3. Now we need to find locus of vertices of families of parabola. So I'll take this as alpha and I'll take this as beta. So in this case, alpha will be simply minus, so it will be minus 3 upon 4a, and beta in this case will be, now 35 into 3 is minus 105, and then 12 into 4 is 48, and it will be simply a. Now we need to eliminate this a, so I'll multiply the two expressions. So if I'll multiply, I'll get alpha into beta as minus 3 upon 4a into minus 105 upon 48a. So a and a, it will cancel, minus and minus will also cancel, 16. So here I'll get alpha into beta as 105 upon 64. So locus of vertices of family of parabolas will be simply xy equals 105 upon 64.